Hello, in this video I'm going to look at creating an amortization schedule. So your book has a nice little example of when an amount is borrowed and it's paid off, like say for example, looks like this is 1 year or so because you have that there's 12 equal payments, but then again it could be 12 years, for example, instead of like, monthly. But see like how you have the amount of a payment is 88.85, then you have an interest for that period, the portion to the principal, and then you have the principal at end of the period. So essentially, once you know the payment, you can find what the interest for the period is by basically multiplying the unpaid balance times the interest per period. Now in that case, once you find the interest per period, then you would just subtract this amount from the payment size or amount, and that would give you a portion to the principal, which essentially means that you take the unpaid balance or the principal at the end of the period and you subtract the proportion to the principal, and then it gives you a new ending principal amount. Then you repeat the whole process again, where you take the unpaid balance, multiply by the interest per period, and then from there it gives you a new portion to the principal, thus giving you a new reduced amount at the end of that period. So you keep repeating that process up until the point that you would want to have a balance of 0, followed by that the last payment may need to be adjusted, for instance. Now that's the purpose of this video, is how do we get the unpaid balance to go to 0, and then how do we figure out the last payment size or even just the amount of interest for that matter. So let's consider an example of which 14,500 is borrowed at an interest rate of 12% compounded monthly for 5 years. Now, in that case, that would mean that we don't really know what the payment is at the moment. So in that case, you would have to recall the formula where you take the principal value is equal to, or the principal present value is equal to the payment size. Then you have that this is going to be 1 minus 1 plus I raised to the negative n, and then all of this is divided by I. Now in either case, n is equal to m times t, and I is equal to r over m. You can actually replace these. Now typically, for example, the book might actually use different notation. So like they might use like an S, and then over here would be your R. But it's more or less the exact same thing, okay? So for here, we know that we need to find the payment first. So essentially, you're setting up kind of like an algebraic equation. But let's go ahead and just write this out. So we know that in this case, 14,500 is the amount that was borrowed, but we don't know what is the size of the payment. So for this, we will just plug in 1 plus, okay, so we plug in r over m, which is 0.12 divided by 12, and all of this is raised to the negative n, which in this case is negative 60. Okay, now we're going to go ahead and just put negative 60, and we're going to divide this by the amount I. But the amount I is 0.12 divided by 12, because essentially this amount was compounded monthly for 5 years, meaning that there's going to be 60 payments. So you have that there are 60 payments that are being made, but again, we don't know what that is. Now, what I want to do is try to reduce this as best as possible before inputting this into the calculator. So I have 14,500 is equal to the payment, which again, you don't know yet. And then we have 1 minus 1.01. and all of this is raised to the negative 60. Now, of course, all of this is divided by 0.01. Now, we can actually close this and then solve algebraically for the payment, because essentially all that you need to do is just take the 14,500 and divide by this amount. Now, most likely you have that the formula, or just doing the division for that matter, is going to tell you that the payment, okay, so the payment is equal to 14,500 multiplied by 0.01, and all of this is divided by 1 minus 1.01 raised to the negative 60. Okay, so this means that we can actually compute what this is equal to. Now, let's go ahead and use our calculator, of which that we'll just say that we know that it's 14,500 multiplied by 0.01, and all of this is divided by 1 minus, so we have to do parentheses 1.01, and then we have to raise this to the negative 60. Okay, now when we hit enter, this is the amount that we would be paying monthly for 5 years, essentially. So we have that that's 322, sorry, 0.54. Okay, so essentially we have that approximately the payment size is 322 and 54 cents. Now, interestingly enough, we can actually compute, for example, what the amount of interest that is paid back is going to be. Because essentially you can take 322.54, multiply that by 60. So this is the amount that I'm paying back minus the amount that I borrowed, for instance. And we have that there's a total of 4,852 and 40 cents. Okay. Now, the purpose of this video is actually not necessarily, just finding the payment size and also the interest that's paid, but again, it's creating this amortization table. So let's actually use Excel at this point because we have everything that we need. So for example, we create a table where we have the payment number, the payment size, the principal, and the interest that's due, and then the principal balance at the end of the period. So here is the amount that was borrowed, which in this case is 14,500. Okay, now we actually do know the payment size. It's 322 and 54 cents. Now here's where it gets a little complex in terms of like, okay, well, how do you find the principal and how do you find the interest? So going back over here, let's go ahead and scroll up just a little bit. Okay, so to find the interest that's due, essentially you have to take the unpaid amount and you have to multiply by the interest that's due per period. So in this case, that would be R over M. Now, one way to think about it is, when you're calculating simple interest, you know that it's P times R times T. But in this case, it's kind of like you're finding the interest rate, the simple interest when you take the principal times the R. But notice that it's, per period essentially. So it's a little bit different in that regard. So I'll just get rid of this for now. And we're going to go ahead and just find the unpaid balance. So to find the unpaid balance, we'll just take the 14,500 and then we're going to multiply by 0.12 divided by 12. And this is going to be the interest that is due. So notice that, of course, what you can do here is that you have, that's really just 14,500 multiplied by 0.01. Then in this case, this is going to tell you how much interest actually is due, which in this case would be 145. So you have that that's going to be $145. Okay, now that tells you the amount of interest that's due, but now you can figure out the principal. So the principal, which some people call it the reduced amount, essentially it's the payment minus the interest. So in this case, it would be 322.54 minus 145, and that's going to tell us how much this is going to be, which you get 177.54. Okay, so this is the amount that would be applied towards the principal. Now, in order to find the ending balance, essentially you just have to take the balance as, okay, so you're just going to take the unpaid balance and you're going to subtract the amount that's towards the principal. Okay, so in this case, notice that the amount that was the balance was $14,500, and you're subtracting the principal of $177.54, which in this case, if you go ahead and you compute that, you find that it's going to be 14,322.46. Now that was just for the first, that was actually just for the first payment essentially. So let's try to do this in Excel, okay? Now, we'll go ahead and see that the interest that's due is essentially going to be equal to this amount, but multiplied by 0.12 divided by 12. Okay, so we hit enter, and this tells us how much interest is applied. Now, if we want to find the principal, then in that case you can do this amount minus this amount, and then just hit enter. So we see that that's the principal that's being applied. Now, how to get the new balance at the end of the period? Basically, you'll take this initial amount minus the principal, and then you just hit enter, and see like how that gives us the same ending balance that we had. Now notice that essentially you can do this again. Let me do this because yeah, it's the same payment, right? Okay, but the interest that's due is equal to this amount, but it's multiplied by the 0.12 divided by 12, and then we just hit enter. Okay, so this is our new interest amount. Let's do this. Okay. Now to find the principal, basically you just do the payment minus the interest that was due, and then you hit enter. So now we have that this is the amount that was towards the principal. Okay, but how do you find the new balance? Well, you take this amount and you subtract the principal and you hit enter. Now essentially I know that this payment is going to be the same up until the very last payment essentially. Now here okay, so here we just need to find the interest that is due. I know that it's going to be this number right here. So multiplied by 0.01 essentially. But let's go ahead and just verify that that does give us what we want. Okay. So see like how it took E4 and it multiplied by the balance of, or the interest per period, which is 0.12 divided by 12. Now over here, we can actually check the principal. Okay, so we know that it has to be basically the payment minus the interest, and then that's going to give us the amount for the principal. So now we just basically check and see that we can get the new balance at the end of the third payment, and there we go. So essentially you're going to be repeating this process over and over, but what I can do here is just go ahead and copy into all of my cells leading up to the very last payment. Actually, this didn't do it right. Let's copy that, and then yeah, okay, so we'll copy and then paste. And now what we'll do is we'll just copy the interest into the remaining cells. Okay, now of course because I haven't updated the balance part of it, in that case it's showing up as 0, and that's why this amount is $322 and 54 cents. I had to actually change it briefly where yeah, I just tell it to initially start at the payment minus the interest, so that way it's a little more clean. So let's go ahead and finish this by dragging. Okay, so essentially we have that the balance started off as 14,500, but then we essentially are paying this off throughout the entire throughout the 5 years essentially. Okay, now here's where things get a little confusing because, well, now we have that essentially this has to be paid off, the $319 and 71 cents. So in actuality, you know, we know that the principal is essentially going to have to be that same amount. Okay, so 319, 319.71. Okay, and we can go ahead and do this if we want. Okay, so see like how we got the 0, right? But now we need to figure out what was the interest that was due. So the interest that's due is based on the remaining balance for the last second to last payment. So we can do this. Okay, so now we see that essentially the payment size is actually going to be equal, let's see, it's going to be essentially this amount plus this amount, and we just hit enter. Okay, so notice that in this case the amount that needed to be paid off was actually a little larger. Okay, so now we can see that the balance has been paid off. Of course, if I wanted to know how much was applied towards the principal, well, we already know essentially that the principal amount, it had to add up to the amount that was borrowed. So we have that did work out. Now, interestingly enough, you can actually figure out, for example, like how much interest was paid back. Now, this is a little weird because if I add all of the interest that was paid, see like how it's 4,852 and 77 cents. Well, look back over here. We figured out that approximately the interest is going to be $4,852 and 40 cents. But that was when we assumed that every payment was going to be $322 and 54 cents. So to kind of explain why is it off by 37 cents is exactly why we had to adjust in the first place. Because if I change my payment to $32.54, then in that case, okay, so we'll do that, and we'll do this. So see like how the principal that was paid is $319.34. Why is that? Because it's basing it on that the payment is going to be the same. So in that case, we're left with a balance of 37 cents, meaning that if we were to add that to here, then yeah, it's going to tell us how much interest we actually should pay in that case. But remember that essentially the amount over here, it needed to be $319 and 71 cents. So we just put that back to fix it, and now this amount is equal to the sum of these two. Okay, so in that case, yeah, we had to pay 37 more cents in order to balance out. Now, of course, if you were to, let's say, pay more on a previous balance, like let's say for whatever reason that you paid back like 350, then in that case you have that. So let's see. Okay, so if you have 350, then in that case, yeah, so we'll have to change that to 350. So notice that in this case, you have that the last amount, the last amount is 292, meaning that in order to balance it out, it's the same thing. You would have to have that you're paying back the 292, and you're paying interest of $2.92. But what is your payment going to be? It's going to be the sum of the principal plus the interest that's due in order to balance to be 0. In that case, that might change the amount of interest that was paid back, especially, you know, like if you said that the amount, the previous amount, like let's say like you did another 350 prior, then in this case, you know, that's definitely going to change everything with regard to, you know, like how much you really do owe. So see like how, you know, this balance is too high, so in that case we just change it back to whatever is the previous balance. And see like how we're drastically lowering our last payment. Okay, and then you see like how the interest is actually going down. So you can repeat that process essentially, but in either case, you know, that's how we would create a amortization table. Let me just fix this. And then this one was supposed to be $319 and 71 cents. And then, yeah, that's increased by 37 cents. Now, a good question that came up was, how do you find the unpaid balance directly? So, like, if I wanted to know specifically what the unpaid balance is of the amount that was borrowed, this is an equation that was given in the textbook. So R is basically the payment, n minus x is the number of payments that remain, essentially. And then you have that I is still the same, it's R over M. So if you want to use like the formulas that were applied in this example, you could probably do like where you say y equals the payment multiplied by 1. So 1 minus 1 plus r over m. And then you have minus n minus x. And all of this is divided by the r over m. So in order to come up with an equation that would determine the unpaid balance, you would essentially use that the payment size is going to be 322.54, and then you have that's going to be 1 minus 1.01 raised to the negative. Okay, so in this case you have that's going to be 60 minus x, and then all of this is divided by 0.01. Of course, using this amount, that's going to result in kind of like it's going to be an approximation, because essentially like when you compare the values, like when you plug in how many payments were made, when you go to your table, you're probably going to notice some like differences. And that's mostly because of the rounding errors that occur, because see like how every payment was 322 and 54 cents, which in this case, like if you kind of go back to the original question, you'll see that essentially it was 322.54 49 and then a little more longer. So if you actually do use this equation, you actually have to use the one that you found at the very beginning, using as many decimal places as possible. Otherwise, when you plug in the number of payments that were made, so like say for example you plug in after 50, then you'll see that when you check after the 50th payment, that the number that remains will actually not be completely accurate. And that's just because of those rounding errors. But in either case, this is how exactly you would create a amortization table if you were to use Excel. Okay, so in any case, like you don't really need to use any kind of special formula, but you do have to just know the whole process of how you can create the table if you know the payment size, or in any case if you know just the amount that was borrowed, the interest per period, and then how many payments were going to be made in that case. Okay, so essentially the table is more or less just a nice little way to keep a regular schedule on how you're getting rid of this debt or loan that you borrowed and are intending on paying back. Because primarily, once you start making these payments, ideally you want that to be zero at the very end.